In this video, we're going to go through an example and demonstration of how to actually work through the lab ionic compounds and formula writing. Now, an example again of something that's ionic is typically a metal and a nonmetal, but you can also have groups of nonmetals that are polyatomic ions that have a charge. So we're going to see an example of some metals and also nonmetals, but also groups of nonmetals as far as polyatomics go. And so on the next couple slides, we're going to see these little designs. And unfortunately, I couldn't find a design, using Google Slides that had a flat edge. I was hoping that it would be flat edge. So hopefully you can see beyond that. But if you think about, for example, a metal will typically lose an electron and become positive, where nonmetals gain electrons and become negative. And so if you lose a metal, we got this little notch that's kind of cut out, where the nonmetal is going to gain that extra piece, and so we have the extra point. So the ones that are pointed in more of a yellow and goldish color, those are going to be our nonmetals typically, in our negative ions, or known as the anions, where the positive ions are these shades of blue, and these are the ones that again have lost an electron. And so we can have a set of 1, 2, or 3, and again, just try to ignore the little lines in between, just as far as I was able to piece this together. And so we have a group of 1 because it's lost 1 electron, so it's +1. This group right here has lost 2 electrons, so it has 2 notches out of it, and it's a +2 ion, where this one has 3 notches because it lost 3 electrons. And then we can also have some ions that are negative. Negative ions, again, are known as the anions. The positive ones are the cations. And so this one gained 1 electron, therefore it's -1. These gain -2, they have 2 points, -2. This one down here, the darker gold, gained 3 electrons, so it's -3. And so what we're doing is you're going to be manipulating these and moving these around and copying them and creating your own compounds based on names that I've provided for you. And when you go through, you need to make sure that your matching set has neutralized itself, so totally it balances out to be 0 when you think of the positive and negative charges. So for example, +1 and -1 is a compound that could work together because it's neutral. We've also completed it and it looks nice and it's together. We have +2, and that +2 is made up of both of these pieces. And then we have the -1 and -1. So if you combine -1 and -1, we get -2, which balances out with our +2. If we have +3 and -3, those balance out. So those are examples of good molecules that you will be creating. And so you need to make sure it's complete. Now, this is just some of the examples. Now, if we look at this one right here, this has a +3 and a -2. That doesn't balance out. This one +2 and -1, that doesn't balance out. I would need to bring another -1 in here to balance that out. And I would need to either bring a -1 in here to balance it out, or I would have to have multiples. Now, if you think about math, and if we have common denominators or common factors that things would multiply into, the common value between 3 and 2, of course, multiplied would be 6. So I'd want them both to be 6. So in order to make this 6, I would need 2 of these 3 pieces. So I'd have a total of +6, and I could have a bigger piece on top. And then I could have a smaller one right here with 2. I'd need 3 of those to make 6. And so we're going to see some examples, and I'm going to show you how that is in just a second here when we get to the next page. But what you are going to be playing around with are these negative and positive pieces based on this third slide. Now, you can either cut them and drag them and move them with you, or you can just copy them. And so in the beginning, if you want to make sure that you've copied them and you don't mess it up, I would recommend you can just copy them, but like I said, you could also cut them as well. You just don't want them to disappear permanently. And so if we take a look at this, you can click on any one of these. If you just click in the corner, that will give you the option or ability to move. So for example, I can take this, and if I have this little cross-looking shape, I can click and move that anywhere, and we're going to be making new things with this. So the other alternative, and I just have this matched up for you guys right now, is once I have it highlighted, I can right click and I can copy. Or if I were to, for example, highlight, and I could go in and I can do Control-C, and that would give me the same ability to copy. And so if we go to the next slide, we have some examples. And I have, for example, zinc hydride. The hydride was different from hydrogen. So Notice I did point that one out. I wrote that as hydride, but not all of these, basically none of these are labeled. You need to do a little bit of research on your reference table using your periodic table and of course table E. Table E is where you're going to find the polyatomics. Again, a polyatomic is when you have multiple atoms of different elements. And so typically the ones we're going to see are multiple elements. There are a couple of just one element, but the ones we have here are all multiple elements. We know that because they have two capital letters. So for example, NH4, we have, for example, PO4, we have CO3, we have SO4. And again, they all have different charges. So make sure you're paying attention. We have NO3, we have OH-1, so on and so forth. And so when we go through, we're going to be actually creating some things here. And so I want to show you an example and also show you how to calculate this. And so one of these is done for you. And when you actually go and do the actual lab, you'll actually have these. I will leave it as completed, but I have one done for you here already. And you're going to be completing them and I'll show you how they are. So for example, zinc hydride, we need to find zinc and we need to find the hydride. Hydride, when it's listed second, hydrogen is going to be the hydride. It's going to be the negative value. Zinc is a +2 ion. Again, if we look at here, zinc is a +2. If you notice, there's some lighter blues up here, then there's some medium blues, and then darker blues, the +2s. Notice the +2s don't have both sections filled in, because I didn't want you to be confused and add them up and call it +4. Just like my +3s, I have not added in the top and the bottom, because I wouldn't want you to say it was +3, +3 to make +9. Same thing with the negatives. The -3 is, again, just in the middle. -2 is just at the top. For these examples right here, it's a little bit lighter. And then the lightest, these ones are all -1. And so when we look, zinc was a +2. In order to balance out +2, I have to have a -2 total. But hydride is only -1. So I actually had to bring in 2 of them to fill it in. And I'm going to show you an example here with the phosphate in just a second. When we're going through and filling in the table, what we need to do is look at what the charge of the cation is. The cation is your positive ion. So what is the charge, for example, up top that you see? Is it plus something or minus something? In this case, my cation is +2, but I only have one of them there. Okay, there's only one piece, and I'm going to show you some different stuff down here. Because of the total, because there's one piece at a charge of +2, I'm going to multiply these two numbers together and I'm going to get +2 for the total cation charge. The anion charge is the charge on my negative piece. In this case, it's a -1 for the hydride. So I would write the -1 charge. But if we look, there's actually 2 pieces that I need. And so I'm going to write that that's a number 2 because there's 2 anions. And so -1 times 2 is -2. So we just multiply these two to get our total anion charge. When I take my total cation charge and my total anion charge, which is basically the total left side and total right side, or total positives and total negatives, it should always equal 0. If I didn't equal 0, then I did something wrong in my math, or maybe I didn't complete everything. So if we go back and look at this, +3 and -2 doesn't add up to 0. +2 and -1 doesn't add up to 0. That would mean I made a mistake. And there's obviously a gap right here, and there's a gap right here, so I'm missing something. When you're done at the end, your formula is going to be written so that you actually have the proper formula. So you may need to revisit things that we learned earlier in this year with the crisscross method. Or if you notice I have 1 zinc. Again, I don't really worry about charges in my formula. I just worry about the number of pieces I have, or the number of atoms I have. So I have 1 zinc and I have 2 hydrogens, so it becomes ZnH2. And if you remember in the crisscross method, this 2 I cross down to my H and my 1 comes over and crosses to the Zn, but I don't have to show the 1, but my zinc number 2 comes over, that +2 comes over, and I end up having ZnH2. So the formula should correlate with how many pieces. I have 1 double piece and then I have 2 single pieces. So let's take a look and show you how you can actually go through this. You're going to make, for example, calcium phosphate. So I have to go through and I have to look at these. And again, there's 2 different ways you can do it. I would recommend just copying just so the pieces are there. But if you want, you can cut them as well just to show that. So for example, if I click anywhere in here, just click somewhere down the corner of the box, it highlights the whole box. If I do Control-C and then I click down on my next slide and I just click somewhere over here and I do Control-V, it's going to bring that piece over. Now I can drag that piece. And so if I have my calcium piece here And then I look at my phosphate. If I go and look at phosphate, phosphate is PO4. Again, I'm going to click somewhere here. And again, I can either Control C, or I can right click and I can go to copy. And then if I come back over here, I can right click and I go to paste, or I can use the Control V option. And then once I get that cross looking object, I can move my piece around. Now, if we move it around, notice it doesn't balance out. Notice I have +2 and I have -3 here. So what I need to do is find some common value between the 2's and the 3's that makes it the whole thing. So let's say, for example, once I'm here, now I can play around with what's here. If I take this and I copy it and paste it again, I'm going to paste my piece in there. And now I filled in that third one, but now I have an extra one here, and it still doesn't balance out. So now I'm +4 and -3. I haven't completely got it correct, so I'm going to play around a little bit, and I want to make sure I have the right number. And we can try to make these as close to possible, make them look nice. And again, I don't know. Again, there's a gap here, so I haven't balanced it out. So let's copy this one and paste another one. We'll move it down, and we'll just try to slide it over just to make it look nice. And now again, notice how I'm still missing pieces. But now I have a nice appearance because now I'm looking at 2 gaps where every other time I only had 1. And so I have a total of -6 over on this side, and I have +4. If I add 2 more, I'm going to balance out. So I'm going to copy that, I'm going to paste it, and once I move that piece over, now the piece is totally complete. We have +6 on the left, we have -6 on the right. So that's the first part, just finding out. And sometimes you'll have ones that are just 1 and 1. Sometimes you'll have +2 and -2. Sometimes you'll have, +3, -3, like the examples that I had on previous slide. Now, when we go through this, the cation charge, what you're looking for, the cation charge is the charge of the cation. The cation is your positive piece. I only need to look at the charge here. So my charge here is +2. I don't need to know the fact that there's 3 of them yet. That number goes here because there is 1 calcium, 2 calciums, 3 calciums. That is the number of cations. That's how many I have. Now I take those 2 and I multiply them. 2 times 3. The total cation charge is +6 because there are 3 of them. When I look at my anion charge is a -3. But I have 2 of them. There were 2 pieces that I used here. So that's a -2. And -3 times -2 is -6. Now, like I said before, those columns should add up. When I take the total cation charge, the total anion charge, they should always add up to 0. Just like +2 + 2 + 2 is +6, -3 is -6. So +6 and -6 balances out to be 0. When we look at the formula, I have calcium, Ca. I'm going to get into, I believe I'm in a superscript. So I'm going to go to calcium phosphate, CaPO4. And what we need to do, we need to consider the control plus button goes superscript, control comma goes subscript. So PO4 is my subscript. We want to look at that, but notice how many I have of them. I actually have 3 calcium, so it's really Ca3, and I have 2 phosphates. So I have 2 phosphate groups, but we need to make sure that we're in a parentheses. And so my parentheses, I don't want PO42, I want PO4 twice. And so we may need to shrink your letters down, the size of your letters. Notice my font was 14, that was a little too big. So I have PO4, I want to make sure that that parentheses is a little bigger, so we're going to unsubscript it. So pressing the control comma again would take away the subscript. And if I put my subscript back there again, highlight it, control comma, makes it look nice and neat. And so we have Ca3, because there's 3 CAs, and then PO4, that's in parentheses. Again, we talked about the MC Hammer rule that I kind of hinted at. Can't touch this, right? So the PO4 always stays the same. It's the charge that crisscrosses. So if we go back to the crisscross rule, the 2 and the 3 crisscross because the calcium is +2, the phosphate is -3. It's the 2 and the 3 that crisscross. So the 3 that was over here came down to the calcium, and the 2 that the calcium had came over to the phosphate. So when we look at that, we want to make sure that we have the correct formula. So I have Ca3PO4. Now, if it is a problem, if you can't, really do this and you can't write it out and it's hard to, manipulate, I can understand and I can accept. So for example, let's just say you wrote it as Ca3 parentheses PO4 twice. Now, again, don't leave it like this. This looks bad. Shrink the text. So by highlighting the whole text and then just go up and you can change the value of how big it is, that will shrink it. If it's too hard for you to go through and to do the subscripts, I'm okay with accepting this, but you got to make sure, for example, that the PO4 is in parentheses because it's a big difference between PO42 like this and PO4 with parentheses and then the 2 after. That's a big difference. Okay, now it looks like there's 2 PO4 groups. But if I get rid of the parentheses, it looks like there's 1 phosphorus and 42 oxygens. So we want to make sure that we have appropriate values. So like I said, if you need to highlight and change, but again, to go through and change the text, all you do, if you want to do the full number first, you can highlight that number and you do control comma, that shrinks it. Again, control comma, and then finally control comma. Unfortunately, you can't do it all at the same time. We're going to do that again with the number 2. I kind of missed it. Control comma brings it down. So again, we get the same value. So if you make a mistake, you can always go back and use the arrows. We're going to undo all of this. I'm going to go back through because of course I didn't want that there. What I really want is my 0 and we will get that in there. So hopefully when you go through, you have some examples just to kind of break down, get an idea of what it's looking for. And what you're going to do, the same thing, you're going to get a blank slate. For example, you're going to see the term, and then you're going to see your chart for each of them. There are 12 to do. Notice some of them are smaller, and as we scroll down, some of them have bigger spaces. And then the last one is one of the biggest ones, very similar to this one that I just did for an example. So in this case, when you're going to look, notice you only have a little space. You might not need to use as many pieces. But some may be a little bit bigger. For example, this one's a little bit bigger, this one's a little bit smaller, and again, you're going to use more pieces. So if you need to use scrap paper, what I would recommend, use scrap paper, write out the word, look up, and see what ions you're going to use, and maybe write out the formula, and when you do the formula, do the crisscross method, and see what the real formula is going to be and what and how many pieces you need. So hopefully you found this beneficial. If you do want to cut and do the cutting instead of the pasting, or excuse me, instead of copying. For example, what you can do if you go through, if you right click on this, you can either cut or you can do Control X. Okay, I can either highlight and then I can go up into cut and I can click that, or I can do, if I'm in my box, again, if I just click somewhere in the box, make sure it doesn't have the middle line because that might only take one of them. You want to just click in the bottom once. If you do Control X, it disappears. Let's say you go to the other page, you can click somewhere and do Control V and that will paste it, and then you could move it around, of course. Now make sure it's under the correct one. Notice this is zinc, of course, so that wouldn't work, but I can bring it down to calcium when I needed that, and then I need my oxide piece. So you can do that, and then that might be another method. As you go through, you'll eliminate most of them. There are a couple extra pieces, but you will use most of those pieces. So it's up to you and how you want to proceed. If you have questions, just leave them below, or submit it to the Google form or through Google Class, or you can send me an email. All right, take some massive action, and I hope you do great on this lab. I'm just gonna kind of go backwards here before we forget, just so again that you will have everything. So when you're seeing this, by the time you watch this video, it should look like this for your examples, and then you have 4 slides, actually 1, 2, 3, 4, 5 slides to complete for a total of 12. You have a dozen. And I've broken this out over a couple days. Again, hopefully you've taken some time to watch the video and understand what's going on. And then you have a couple days to actually go through and do this, move and manipulate the pieces, and make sure everything's balanced. All right, take care and good luck on this lab.